Hi, this is Beverly,
and
this is a presentation of my final project, which is on Impala. Impala is a
real-time
SQL
query
capability, real-time big data query capability.
Hadoop and
it's massively parallel, allows you to do SQL queries, and runs on Apache Hadoop.
Interactive views.
Impala gives you query speed that's fast enough for interactive use. Normally, MapReduce jobs have a significant startup time,
benefits
which
of
makes
Impala
them
is
too
that
slow
it
for
doesn't
an application
move
which
your
requires
data in and
real-time
out of
response to
HDFS
your
or
users.
HBase or transform it.
So some
runs
corporate
queries
information.
on the data as it
Impala is a
resides
Cloudera
there.
project. It is Apache licensed open source software.
It uses standard SQL.
If you want, there's an
allows
enterprise
existing
version
BI tools
for
to access
support.
data that is in HDFS.
Some of the
or
benefits of
HBase.
Impala
It's
are
very
that
fast,
it executes
10 to 100
query
times
without a
faster
need
than
for
Apache
moving your
Hive or
data
Stinger.
in and out of HDFS or transforming it.
You can do SQL queries on
It
trillions
supports
of rows,
a diversity of
join
unstructured data formats, as opposed
It does
to
not have as
RDBMS
much SQL
tables, which
capability
require
as
you
Hive.
to set
For
up
example,
what your tables
XML
look
or
like
JSON
and
SQL,
not change them.
functions.
Because it
main interesting
supports
thing about the
standard
Impala
SQL
architecture is that
interfaces,
it
it allows
use
existing BI
MapReduce.
tools to
It
interface with
uses,
the data that's stored in HDFS
direct
or
access
HBase.
of the data resident in
And it's also
HDFS
significantly
and HBase.
faster than Apache Hive or Stinger.
Quickest way to get
Approximately
started with
10
Impala
to
is to download the
100% faster.
Cloudera Quick Start VM,
So
which
some more
has Impala
benefits
installed.
are that it uses the same
So
metadata.
for my project, I
ODBC,
downloaded two
and
data
SQL
sets.
syntax
One was a census data set
as Hive.
that had
So if you have
total
applications
population
that are built
numbers
on Hive, you can
by zip code.
port those over to
And the second data set I
Impala
downloaded
without
was a
making
zip code
changes
lookup
to your
table
code,
that translated
at
zip
least
codes and told me what
only
county and state
insignificant
they were in.
changes.
One thing that
So
I found
with,
in playing around with
Impala,
is
you can
need to
do
make sure that you
SQL
run
queries
compute
on
stats
trillions
on
of
your
rows of
tables
data,
to get
which
good
is more than you
performance.
can do in a typical RDBMS
So some of the
database.
questions I was able to ask
and
of
also you can
my
do join
data as
clauses,
it
which is not
resided
supported by
in
all
Impala
SQL engines.
was, okay, what are the
running
highest
big data.
population zip codes? And it turns out that that's
So some drawbacks
partially
of
correct.
Impala is it
And
does
some
not
of the
support
lowest population
all the
zip
SQL
codes
capabilities that Hive
around
does.
Tallahassee,
For example,
or maybe Miami.
But
Certain
actually, that's aggregating
data errors
statistical
to me because it
functions,
says
like
to
for
me
example,
only 1 or 2.
variance. They're supported by Hive QL, are not supported by
I then
Impala.
did some slightly more
Also,
complicated SQL queries
XML
where I grouped
and JSON
my zip codes
functions
up
are not
by
supported by
states
Impala.
and asked.
It also has a
for one of the
limitation
largest
that when you do
population
order by
states,
clauses,
which
you
turned
also
out
have to
are
include a limit
California and Texas and
clause,
Wyoming,
which
is
means
the
it's
least
going to
populated.
reduce the number of returns.
Getting slightly more complicated, I did a little more math in my
It also does not
SQL statements
support
and found
update
out
SQL.
that
That's
the
because
state
it's not a
of Puerto Rico
transactional database.
has the
It's
highest percentage
more
single
geared
mother
towards
households,
bulk updates.
and the state of Hawaii has the largest percentage households.
Part of what's special about the
greater
Impala
than 6 years
architecture
old.
is it actually
Thank
does
you.
not use MapReduce to access the data, and that's how it's able to get that real-time query capability. What it does is it has its own architecture that accesses the data as it resides in HBase or HDFS without going through MapReduce. So if you want to install Impala, the easiest way to get started is to download the Cloudera Quick Start VM. Impala is installed on that by default. As I've said before, it does not have a dependency on MapReduce, so if you're putting it in installing from scratch, you don't have to install MapReduce. You do have to have at least a 64-bit OS and 8 megabytes of RAM. Actually, that should be gigabytes. So to get started, I suggest you do what I did and download the Cloudera 5.0 VM, which includes Impala 1.30. So what I did as a project for Impala is I downloaded two different data sets. One was census data from 2010, and I created a table in Impala that includes all that information. So it has census data rolled up by zip code, and it has like the population in that zip code, the population that's male, female, households of single mothers, single fathers, households with older folks and younger folks, and more folks and less folks. One thing to notice about this create table statement is the external keyword there. What that does is it tells the create table, the table structure actually looks at the data as it resides in HDFS. So if you see at the bottom of that create table statement, it says location, and then it gives a path. That's actually a path to the location of the data in HDFS. And the row before that, where it says row format delimited fields, that actually describes the format of the data as it resides in HDFS. For example, I uploaded a CSV, so comma separated file, and that row right there describes that format. So secondly, I also found a zip code table so that I could do a join between my census data and get more description of where those zip codes are. Like it tells me, for example, the city and the state and the county in which the zip codes are. So that's my create external table statement for the zip code table. So when I started doing joins, I encountered some issues with performance with Impala, which required me to do a little research. One thing I found is that if you want to do any significant things in Impala, you need to do compute stats on your tables, which allows it to count the number of rows, etc., to optimize your queries. I did find that on the zip code table, it did not do very well with that compute stats function, and I tracked that down to a bug where it does not compute very efficiently on a single processor machine. Through just a little monkeying around, what I've found is that if you delete a lot of your string fields, then that gets around the problem. So that's just what I did. I deleted the, like for example, that acceptable, unacceptable, time zone fields, just kind of minimize the data in my table, and then it was able to compute stats just fine. So this is the output of some queries that I got running in Impala with those two data sets. First of all, I asked myself, okay, so what are the most populated zip codes in the United States? So on the right there, that's the SQL query to get at that answer. You see it's using a where clause to join the two tables, and then it does order by population, descending, and gives me the top 10 most populated zip codes. And I, in the inverse, did the same thing for the least populated zip codes in the United States. And it pulled back a few that were zero, so I excluded those as well. So getting to some slightly more complicated SQL statements using my two data sets, I then did some roll-up and asked myself, okay, so what are the most populated states and the least populated states? To get at that, I had to group by my states. So it rolled up all the zip codes that are in the state and summed it up. So you see that sum aggregation function in my SQL statement. And then again, ordering by that aggregate of the population in each state. And so finally, I asked it a slightly even more complicated question, and that are these two things. So what are the states with the highest percentage of single mother households? To do that, I had to get slightly more complicated with my SQL statement, and you see that I'm actually doing some math there in my select clause where I'd sum the total population, total number of households that have single mothers, and then I divide it by the sum of all households. So that gives me a percentage, and then I have to do the exact same thing in the order by clause to order by that amount. And similarly, I did the same thing to determine what are the states that have the highest percentage of individuals who are 60 or plus years old. And interestingly, the answer to that was Hawaii, which I wouldn't have guessed, and Florida, which I would have guessed, and PR, which I believe is Puerto Rico. And that is all I have. Thank you for sitting through my introduction to Impala.